Hi everyone, in this video we're asked to simplify and state restrictions. So here we have two rational expressions that we're subtracting, and we have x plus 1 over 4x squared minus 49 minus x over 2x squared minus 5x minus 7. So the first thing that we're going to do is factor. So we'll have x plus 1 over 4x squared minus 49 factors to the conjugate pair 2x plus 7 times 2x minus 7, because 4x squared minus 49 is a difference of squares, so it factors to this conjugate pair, or this conjugate product. So we have x plus 1 over 2x plus 7 times 2x minus 7 minus x over here we have to factor 2x squared minus 5x minus 7. We can factor that using guess and check strategy. So we'll try 2x here and x here, and then we'll try minus 7 and minus 1, and then we'll see if the middle term is correct. So the middle term comes from multiplying negative 7x, or sorry, negative 7 times x, which is negative 7x. Negative 7x minus 2x is minus 9x. Okay, so I made a mistake because these signs aren't correct. This should be minus 7 and positive 1, because negative 7 and positive 1 have to multiply to negative 7, which if I would have had negative 7 and negative 1, it would have multiplied to positive 7, and then the middle term definitely would not have been correct either. So now let's check the middle term to see if we fixed our mistake. I have negative 7x plus 2x, which is negative 5x, so I've factored correctly. So now I'm going to write out any restrictions on x. So I have the restriction that x can't be negative 7 over 2, x can't be 7 over 2, and x can't be negative 1. Because in all three of these cases, it results in division by 0, which is either undefined or indeterminate. So now we can go ahead and we can find a common denominator for each of these fractions, or each of these rational expressions, I should say. Notice that if I look at the denominator of 2x plus 7 times 2x minus 7, in order to find a lowest common denominator, I have to multiply both the numerator and denominator by x plus 1, because it's missing this factor of x plus 1. So I multiply the numerator by x plus 1, and x plus 1 times x plus 1 is just x plus 1 squared. So in the numerator I have x plus 1 squared. Now in the denominator, I'll have 2x plus 7 times 2x minus 7 times x plus 1. For this second fraction, I have to multiply the numerator and denominator by whatever factor is missing, which is 2x plus 7 in the second denominator. So I have to multiply the numerator by 2x plus 7. And I have to multiply the denominator as well. Effectively, all that I'm doing is just multiplying this entire rational expression by 1. So I'll multiply by 2x plus 7, and I get 2x plus 7 times 2x minus 7 times x plus 1. Now that the denominators are the same, I've found a lowest common denominator. I can go ahead and I can subtract their numerators. So I have x plus 1 squared. Well, okay, x plus 1 squared minus x times 2x plus 7. I was just going to say that if you wanted to, you could have you could have expanded x plus 1 squared in the same step. And in the denominator, we have 2x plus 7 times 2x minus 7 times x plus 1. Now we can go ahead and simplify the numerator. If I expand x plus 1 squared, I get x squared plus 2x plus 1. And then if I distribute the negative x into 2x plus 7, I get minus 2x squared minus 7x. And this will be all over 2x plus 7 times 2x minus 7 times x plus 1. Lastly, I can go ahead and I can actually subtract and combine like terms. X squared minus 2x squared is minus x squared. 2x minus 7x is negative 5x. And I still have the plus 1 constant term. And that's all over 2x plus 7 times 2x minus 7 times x plus 1. And again, if you wanted to, you could have, since the highest degree term in the numerator is negative, you could common factor out negative 1 to make this look a little bit neater, but that's not required. So then we can go ahead and write the restrictions, and we have that x cannot be equal to minus 7 over 2, negative 1, and positive 7 over 2. That concludes this video.